So now we're going to start taking those three-dimensional solids and figuring out how to find surface area. So this is section 10-4. I realized that we did skip some sections. Don't worry about that. So here is section 10-4. It's surface area of prisms and cylinders. It's going to go on pages 102 to 103 of your notebook. The learning target for today is to learn and apply formulas for lateral area and surface area of prisms and cylinders. Okay, so we're going to talk about the difference between lateral area and total surface area, which is one of the reasons why we classified some of the sides differently when we talked about the nets, so that hopefully it made it easier to identify each of those different things today. Okay, so you will need a calculator for today. You also need your yellow set of notes that says surface area prisms and then right below cylinders. You're going to go ahead and fold that piece of paper in half and then cut along the dash line so that it opens up. We're going to use this over the course of 2 class periods. So we are going to go ahead and just do kind of the front and the inside of that front page today. And then we will save the remainder for next time. Okay, I want you to get comfortable with finding the surface area of just solid three-dimensional figures before we take and start doing a composition of three-dimensional figures. Okay, that is to come. But today we're just going to focus on this part. So go ahead and have that. I'm going to use highlighter, calculator, pencil, and we'll go ahead and get started. Okay. Set that aside. All right, so we're going to focus on the prism first. I think the prism is a little bit harder, so we can talk about that and then use what we learned to help us apply it to cylinders. Okay, so there are 2 different ways you can think about surface area. Okay, so I'm going to kind of talk through it using both ways so that you can kind of see the difference and pick which one works best for you. Okay, so when you are doing surface area for any three-dimensional figure, you can do so by looking at the net. Okay, that net is what you would unfold in order to create that three-dimensional figure. You could look at the net and then figure out how to find the area of each of the individual pieces of that net and add it together. Or we are going to use the net to kind of generate a formula. So sometimes people love formulas. Sometimes formulas make things easier. Sometimes they make them harder. So I'm going to kind of show you how to use both as we continue to study surface area over the next week. Okay, so here we go. If I have a hexagonal prism, the first thing I'm going to do is I'm going to go ahead and sketch out the net. Okay. So first thing with the net, it's not going to be drawn to scale. Okay, so I have 2 hexagonal bases, okay, and that means that I would have 6 rectangles that connect. And if this is a regular hexagon, which it is, then all of the rectangles would be the same rectangle. So I'm going to go ahead and try and sketch a regular hexagon. Okay. This is a base, so I'm going to just label it a base, and I'm going to connect it with rectangles, and then I'm going to mirror that hexagon on the other side, or try to, okay, and label it with a base. So I'm knowing for my own personal self that those 2 hexagons should be congruent. Okay, then I'm going to go ahead and just add on some rectangles that are the same to that first. So there's 2, 3 rectangles. I need a total of 6, so I'll make some on this side too. Why not? It doesn't matter which side, if you put them all on one side or you kind of center it. So 1, 2, 3, 4, 5, 6. Okay. And these sides right here are all my lateral sides. Okay, so L, 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 L. So those are all lateral sides. Okay, so that's just kind of like what we did in the last section. So let's talk about how we could find the area of just the lateral, because we're going to break surface area into lateral area and then total surface area. Okay, so let's talk about them separately. So here, lateral area is going to be that rectangle right here. So when I find that area, we're just going to highlight it. This right here is going to be my lateral area. So instead of finding each individual rectangle, which you definitely could, I'm going to start kind of deriving a formula. Okay, so instead of finding the area of one rectangle and multiplying it by 6, because they're all the same in this case, they won't always be the same, but in this case they are, I could instead focus on this overall rectangle. Okay, so that's going to be the rectangle here. So I want to think about how do I find the area of a rectangle. Okay, I do base times height. Okay, but the base and the height are going to represent different things in terms of the hexagon. Okay, so I would have to multiply this dimension here, that blue one, by, let me get a different color, this pink one. So if I wanted to find the overall area of that rectangle, I would have to know this blue length times that pink length. Okay, so if I think about folding this up, okay, so like folding this up, all of these rectangles would fold around, right? All the rectangles would fold around that base. Okay, so if I were going to outline that here, that blue here, it would look like this. Okay, so if I open that up right here, that would unfold to be this blue line. So really, that's the perimeter of the base. Okay, so this length of the rectangle is going to completely wrap around that base, so it's going to be the perimeter of the base. And then this per right here, so I guess I could label that for you. Let me get my pen. Sorry, I'm a little disorganized. Okay, so here, this is, I'm going to call it P for perimeter of the base. Okay, and then that pink side right there, if I were to highlight it on my hexagon, okay, remember it's the rectangles, right? So here was the bottom of the rectangles. This right here would be that length. So I'm just going to go ahead and highlight it here. That's the height of the prism. That's what determines how tall it is. And it has to be perpendicular to the base. So right there, or the side that connects the two bases, you can kind of think of it that way. So this connects the two bases together. That's the height of the prism. Okay, that's the height of the prism. All right, so if I were to put that together to find lateral area, I'm just going to label LA, is equal to P, which is the perimeter of the base, times H, which is the height. Okay, so if you find the perimeter of the base and you multiply it by the height of that prism, you will get the lateral area, or all those parallelograms or rectangles that wrap around it. Okay, again, if the formula is overwhelming to you, you could just find the area of each individual one and add it together. Okay, then we're going to talk about surface area. Okay, so what surface area is it is lateral area plus the bases. Okay, so for complete surface area, you have to take the lateral area, but then you have to add the bases on. So here, lateral area is P times H, right? So I'm just going to do P times H plus, here's the hard part about the formula, is the area of the base changes depending on what shape you have as the base. So we have to keep it kind of general. So this is going to be 2 times capital B, where that's the area, oh, I'm running out of room, where that's the area of a base. Okay, so B is the area of the base. We're going to multiply it by 2 to get both bases added together. So that's the surface area. Okay, so I'm going to go ahead and just highlight those for you so that we have them for our formulas. Okay, so lateral area, perimeter times height. Surface area is perimeter times height plus the area of both bases added in. Okay, so let's go ahead and do an example. We're just going to do one. I kept it the same, a hexagon. Not only does it review how to find the area of the hexagon, but it also connects to that first example we saw. Okay, so let's imagine I have a hexagonal prism, looks something like this, although this is not the right dimensions, where this is 6 meters, so it'd be a lot bigger, right? And this is 10 meters. And I want to find the total surface area, or I want to find the lateral area and surface area of that figure. Okay, so we're going to go ahead and break it up. I'm going to do this using the formulas just to show you, but if you want to make a net and do it that way, you can as well. Okay, so I'm just going to start out by organizing myself with my formulas. So from the first side, I know that lateral area is P times H, and surface area is P times H plus 2 times the area of the base. Okay, so I like to just organize myself by writing down the formula. Okay, so here, perimeter of the base. So I'm just going to go ahead and outline that the same way. So perimeter of the base, that's a regular hexagon, and I know each side is 6 meters, and there are 6 sides. So to find the perimeter, that would be 6 times 6, okay? And then the height, again, I'll just label it in the same color we did before, connects the two bases together, so that height would be 10. Okay, so to find all the lateral sides combined, it would be the same as 6 times 6, which is 36, which is the perimeter, times 10, which would be 360 meters squared for lateral area. All right. Now, some people are like, why would you need to know the difference between lateral area and surface area? Well, when you think about things, not everything is made out of the same materials when things are created. So in case, like this one has kind of a foam base, but metal sides. So sometimes as you're creating figures, you need to know the area of one thing compared to the total surface area of the other. So there are reasons where you would want to know one versus the other, so that's why they have a way to separate it out. Okay, so for surface area here, I already know the lateral area, so I could go ahead and just substitute in 360 there. Plus 2 times, I have to find the area of the base. Okay, so I'm just going to go ahead and find the area of the base down here, and then I'm going to plug it in up here. Okay, so I know to find the area of a hexagon. Okay, so I'm finding the area of this hexagon. I'll just highlight it right here. That I can do so by breaking it into triangles. So here, there would be 6 of these triangles within that hexagon. So I could find the area of that one triangle and multiply it by 6. Okay, so hopefully you remember that from before. So you first have to find the angle at the top here. And to do that, I would do 360 divided by 6 triangles coming to the center. So that would be 60 degrees. Okay. All right, now remember, I used the right triangle right here to help me get some information. So I'm going to go ahead and draw my little right triangle a little bigger. This would be 30 degrees. I know the whole side length is 6, so this side of the triangle would be 3, and I need to solve for the apothem, okay, or the height of that right triangle. This is where it's really important to start using apothem because height is something else, okay? This is why we have some different letters or different ways to say things. Okay. So if I have a 30, 60, 90 right triangle here, and I know the small side is 3, then I know to get the apothem, I'd multiply by root 3, so this would become 3 root 3 would be the apothem. Okay, so the area of the base, what I'm going to do is I'm going to find the area of this whole triangle right here. Okay, base times height divided by 2, then I'm going to multiply it by 6. Okay, so the area of the base, I'm going to do capital B, is area of this triangle. So base is 6 times the height, I now know is 3 root 3, divided by 2 times 6 of those triangles to get the hexagon. Okay, so here I'm just doing the area of the triangle times 6. Okay, so then I would use my calculator. So, oh, that's great. My calculator's not here. That's okay. I can do this by hand. So 6 times 3 is 18. 18 times 6, let me just do it on the side here. 18 times 6 is 108, and then divided by 2 is 54. Okay, so this would be 54 root 3 for one base. Okay, so one of these hexagons would be 54 root 3. So I could plug that in here, 54 root 3. Now remember, I'm doubling it because there are 2 bases. So now I could make that 360 plus 2 times 54 is 108 root 3. And that right there, they're not like terms, so I cannot combine them. So my surface area is just going to be 360 plus 108 root 3, and that would be in meters squared. All right, there we go. It's going to take some practice. All right, we will get there. I will help you. All right, for surface area for cylinders here. This one is going to be a little easier. I always think cylinders are easier than prisms. Prisms are going to be your hardest because the base always changes. Okay? In this case, the base is always a circle, so the formula is always the same. I don't have to keep it generic. I can just write the area formula for every cylinder. Okay, so what we're going to do is we're going to start with a net again. Okay, and remember for a cylinder we have that rectangle that curves up around to form the lateral face. Okay, and then I have my two bases. Okay, so this is a base and this is a base. Okay, we are going to talk about again the lateral area. Okay, that is going to be the rectangle, and then the surface area, which is going to be that rectangle combined with the bases. Okay, so the lateral area here, again, I would have to find the area of that rectangle. I'm going to do it the same way I did before. So I would have to know this base of the rectangle. Well, if you think about how that curves around, that would have to curve around this circular base. Okay, so that's going to be the same as perimeter of a circle, which we call circumference. Okay, so this part right here is going to be the circumference. Okay, which I am going to do 2 pi r. Okay, I'm going to do that instead of the one with diameter so that our whole formula is in terms of the radius and not switching back and forth. Okay, so this is going to be 2 pi r, which is the circumference. And then I would have to be able to multiply that by the height to find the area of this rectangle, base times height. Well, that again connects the two circular bases, so that's the height of the cylinder. Okay, so we are just going to alter this in a little bit because the perimeter is always the same. So here, where the perimeter changes, depending on what shape we have, here the perimeter of a circle, a circumference, is always the same formula. So we can get a little bit more specific. Okay, so base, which is 2 pi r, times the height is h. So 2 pi r times h will give you that area of that rectangle that curves around. Okay, I'm going to go ahead and highlight that for us so that we have it. Okay, then we're going to do total surface area. So surface area is going to be the lateral area plus the two circles. Okay, just to kind of break it up for you. So lateral area is 2 pi r h plus, to find the area of a circle is always the same. Okay, so this is going to be 2, and to find the area of a circle, it's pi r squared. Okay, so this to find the area is pi r squared, and we're just multiplying it by 2 because there are two bases. Okay, so here, there we go. All right, so again, we're just going to do one example, and then we will be done, and we will practice these. Okay, so here we go. It says find the lateral area and surface area of the cylinder below. Okay, so I have a cylinder here. Here are the circular bases. This would be the height. So remember, the height connects the two bases. So even though it's kind of laying on its side, it's still the height because it connects the two bases. Okay, so I'm going to start by organizing myself. So I'm going to do lateral area is 2 pi r h, and over here I'm going to do surface area is SA equals 2 pi r h plus 2 pi r squared. Okay, so I'm just going ahead and organizing. Okay, so what's nice is if you scan these formulas, you need two things. You need to know the radius and the height. Once you know the radius and the height, you can just kind of plug in and simplify. Okay. So notice here I have 2, and that's for the whole distance across that circle. Okay, so that's the diameter. So we could take that, split it in half to get the radius. So the radius would be 1 in this case. And then the height connects the two bases together. So this right here is the height would be 8. All right, so I'm going to go ahead and plug it in. I'm going to leave my answers in terms of pi. So this is going to end up being a nice answer. Okay, so here 2 pi, radius is 1, height is 8. Leaving things in terms of pi, I'm going to multiply everything together except for the pi. So 2 times 1 is 2, times 8 is 16, so this becomes 16 times pi, and that would be in meters squared. All right, not so bad. So now I already know that this 2 pi or h is 16 pi. So no reason to do it again, right? I've already just done it right here. So then I'm going to add that to 2 pi, radius is 1, squared. Okay. Then I'm going to simplify just this part. So 1 squared is 1. 1 times 2 is 2. So this is just going to be 16 pi plus 2 pi. Those are like terms, so I can add them together. 16 pi plus 2 pi is 18 pi. So the total surface area of this cylinder would be 18 pi in meters squared. All right. So I think you'll find, most people, the cylinders are going to be a lot easier than the prisms. The prisms are going to kind of slow you down a bit. Stay patient. It's okay. You'll get through it. I will be here to help you, but they do take a little bit more work. Cylinders are usually pretty straightforward. All right, so we will work on this in class before going on to the second part of these notes. I'll see you soon.